Okay, in this video we're dealing with operations of functions. Functions can be combined using addition, subtraction, multiplication, and division to create new functions, and then eventually we'll compose functions as well. To add two functions to find f plus g of x, and notice that notation there. The combination of f plus g is written like this, and our of x is written outside. We can simply take our f of x and we add g of x to it. The same way, and we probably know what the rest of these are now, f minus g of x would be f of x minus g of x. It can be written either way. F times g of x is f of x times g of x. And then f divided by g of x would be f of x divided by g of x. Now it says the domain, and this is probably the hardest part of this. The domain of a new function is the intersection. Now, when I say intersection, here's what I mean by intersection. It's an and statement. And we'll understand that as we work why that's true. But it's the intersection of the combined functions. Or the combined, you could actually put domains there. The domain is further restricted with the quotient. So we've got to find the intersection for the other ones. And then one step further, in the quotient function, remember that you cannot divide by 0, so it's further, again, it's restricted because of the g of x there's no way it can equal 0 because you can't divide by 0. So example 1, let's scroll down. We're asked to find f plus g of x. So again, all we're doing is here we're going to do f of x plus g of x, and it's as simple as that. But again, we've got to state the domain of the two. So f of x plus g of x is x squared plus x. There's f of x plus 3x minus 1, which is g of x. To add those two functions, we're just combining like terms. It's going to be x squared. Combine your x's will be plus 4x minus 1. Now, here's what we're going to do for the domain. Let's find the domain of each of these, because the domain of the combination is going to be the domain of the overlap. So f of x has a domain where what can x not be, and there's no restrictions there. It can be anything. And the same thing here. There's no restrictions for linear functions. So the domain of our combination here is going to be all things from negative infinity to positive infinity. So that one was pretty easy. Okay, next up we're going to be finding f of x minus g of x. And again, f of x was x squared plus x. We're going to subtract g of x. So anytime we're subtracting, we do have to make sure that we put our parentheses here. So here's f of x minus g of x. Distribute that negative in front of our parentheses will be a minus 3x, and it changes the minus 1 to plus 1. Again, combine like terms. 1x minus 3x is a negative 2x. And just for extra practice, that is correct, but we could go through, that's a perfect square trinomial. You could factor it and you could write it either way. The domain, again, we're going to go back to our domain of our two functions. The domain of a combined function is the overlap. We've got to, here's the thing, we have to satisfy, because these functions involve both. So therefore, in order to be in the domain of both combined, then we have to satisfy both of these. So pretty much we have to be in the first one, and it has to be a member of the second one. But since there's the exact same domain, for every one of these, my domain is going to be negative to positive infinity. With the exception of once we get to g of x, or division, we've got to be a little bit careful because the bottom cannot be 0. Okay, C part, we're going to find f times g. So we are simply taking f, which is x squared plus x. We're going to multiply it times g, which is 3x minus 1. This is going to be simple distributive property. So we're going to take x squared, multiply it by both over here. That'd be 3x to the third minus x squared. We then take x and multiply it by both. That'll be plus 3x squared minus x. Combine our like terms, and you have 3x to the third plus 2x squared minus x. You can leave your answer like that, or you could write it into a factored form to where we pull out an x, so it'd be x parentheses 3x squared plus 2x minus 1, and we could try to factor that farther, or again, you can just leave it as this trinomial, quadratic or cubic trinomial. Again, the domain would be the exact same, negative to positive infinity. Okay, now D part, and again, this is the one we've been waiting on, f divided by g. And we knew that f was x squared plus x divided by g, which is 3x minus 1. Now, there's not a whole lot we can do there. As far as simplifying, we could try to factor. Nothing's going to cross out. Nothing cross cancels. Make sure we don't try this, because the rule was if you're going to cancel out part of a binomial, you would have to cancel the whole binomial. So we can't do that. So that's pretty much your answer. That's f divided by g, but the domain, that's where we want to spend our time. The domain, what could x values be? Now, up to this point, the combined f of x and g of x domain has been negative, positive, infinity. However, there is a problem here. We know that the bottom cannot be equal to 0. So what we're going to come over here and we're going to ask ourselves, what would make it equal to 0? Move the 1 over, divide by 3, and you get 1/3. So therefore, if I were to put a 1/3 right here, I would have something divided by 0, and that can't be. So with my domain, I've got to throw that one value out. So instead of negative to positive infinity, I'm now going to be negative infinity to 1/3, throw out 1/3, and then 1/3 up to positive infinity. So that's going to be my new domain. Or you can just simply say x cannot be 1/3. And when you say that, you're pretty much saying that x could be anything except for 1/3. Okay, the next one. Now we've got a little bit of a domain restriction. F of x, the domain here, x can be anything. That's a parabola. You can square any number you want, add 9. So your domain for the first function is negative to positive infinity. The domain of the second function, what can I take the square root of? I cannot take the square root of negatives. So my domain there is all things from 0 to infinity. So the domain of any combination is going to be the overlap of those two. Now let's draw a number line, and just to show you that my first domain is negative to positive infinity, which would be all things. My second domain is simply from 0 to positive infinity, which would just simply be these. So the overlap would be anything from 0 on. So my domain for f plus g, f minus g, f times g will be all things from 0 to infinity. Now, when we get to f divided by g, we might have to throw out some other value that might interfere with division by 0. So f plus g, we simply do x squared plus 9, which is f, plus g, which is root x. There's nothing that combines there, so that's done. And the domain of that function, again, would be from 0 to infinity. To subtract, you take f, which is x squared plus 9, and you do minus g, which was also root x. There's nothing you can combine there, so there's f minus g, and again, the domain is all things from 0 to infinity. To do f times g, that'd be x squared, let's see, x squared plus 9 was f, times g, which is root x. You can maybe distribute, that'd be x squared root x plus 9 root x is about all you can do there. Or you could have left your answer like that. And again, my domain is from 0 to infinity, because that was, again, the combination, the intersection of the two domains from before. Because, again, those are the values that satisfy both of these functions. Now, f divided by g, that was x squared plus 9, divided by root x. So instead of the domain being 0 to infinity like it was before, we're going to have to throw out any value that's going to make this bottom equal to 0. So what would make the square root of x equal 0? We could get rid of the square root by squaring. Regardless, we're going to get x is 0. If I were to plug in 0 for the x, I'm dividing by x. So 0 cannot be in my domain, so we could very easily remove that just by not including 0. So now it's all values from 0 to infinity, not including 0. Another one of the same. 2x to the third. You can check the domain there. The domain for 2x to the third, you can plug in anything. X squared minus 4x, you can also plug in anything. So these combined domains will be all things from negative to positive infinity. So we have x squared minus 4x. We've got to add f, which is 2x to the third. Not a whole lot you can do there. I'm going to put them in order just because I like to have them in order, in descending order, and that's it. And my domain is going to be all values from negative to positive infinity. Number 2, f minus g. So you have f, which is 2x to the third, minus g, which is x squared minus 4x. Make sure you put it in parentheses to make sure that you're subtracting the whole thing. So it'd be 2x to the third, subtract x squared, and minus 4x would be a plus 4x. There's no like terms. And again, my domain would be all values from negative to positive infinity. C part, f times g. Again, f is 2x to the third times g is x squared minus 4x. I'm going to distribute that. That'd be 2x to the fifth minus 8x to the fourth. That's the product. And my domain, same thing. Then finally, f divided by g, there will be something we might have to throw out here. So that'd be 2x to the third is f, divided by g is x squared minus 4x. So the bottom cannot equal 0. So what I need to do, since that's quadratic, I need to factor that to see what values would give me 0. And to factor it, all I got to do is factor out an x, and you're left with an x minus 4. Set each of these equal to 0, and you see that x equals 0 and x equals 4. Either one of those would make this bottom equal 0, so we're going to have to throw those out of our domain. So our domain is now everything except for these. So I can either say x is not 0 and x is not 4, or I can say x is all things from negative infinity up to 0, or anything from 0 to 4, or anything from 4 to infinity. You can write your domain in either way. Okay, let's find the domain of each of these. So we're going to see what our combined domain would be. Our first one, I cannot divide by 0. I do see a restriction there. So I can have anything from negative infinity to 0 or anything from 0 to infinity, but x cannot be 0. The second one, I see what's the issue here is. If I were to plug in a negative 2 here, I'd be dividing by 0. So for my second function, x could be anything from negative infinity up to negative 2, or it can be anything from negative 2 up to positive infinity. Now I've got to combine those two. So my first one is a combination of x can be anything. We put 0 and negative 2 on my number line. So for my first function, x can be anything except for 0. For my second function, x can be anything except for negative 2. So now we ask ourselves what values are present in both, because in order to be in the combined, it must be in both. This value is not in both, and obviously this value is not in both. However, every other value is in both. So every value from negative infinity up to negative 2, or every value from negative 2 to 0, or every value from 0 to infinity. Or we could just simply say x can be anything except for negative 2 or 0. That's going to be our combined. X can't be one of those two things because you see those were the two excluded values. So first off, let's find f plus g. Here's f plus here is g. And let's remind you on how to add these rational functions together. You do need a common denominator. So you have an x plus 2 and you have an x over here. So top and bottom on the left side, I need an x plus 2 because there's one over here. So let's multiply top and bottom by x plus 2. Over here, I need an x because I don't have one. I have one over here, but I don't have one over there. So now I have my common denominator, which is x times x plus 2. And now on top, I have 1 times x plus 2 plus 2 times x. So let's combine our like terms. X plus 2x gives you 3x plus 2 over x times x plus 2. So that's our final answer. B part, we've got to find g minus f. G was again 2 parentheses x plus 2. And we now want to subtract 1 over x. You're going to do the exact same common denominators. You're going to multiply top and bottom here by x. You're going to multiply top and bottom here by x plus 2. Now, again, the one thing that people miss is when they'll distribute the 1 to get rid of these parentheses, which is wrong. You've got to distribute, anytime you have subtraction, you have to distribute that minus with it. So your denominators are x times x plus 2, which again shows you why x can't be 0 or x can't be negative 2. Let me get rid of those. So on top you have 2x from here. Distribute your -1, and that gives you a -x and a -2. So on top you now have 2x minus 1x, which is 1x minus 2 over x times x plus 2. Nothing factors, nothing crosses out, so that is your final answer. And you could put that top in parentheses if you would like to. C part. Okay, in C part I'm doing g, which we said was 2 over x plus 2, and you can put that bottom in parentheses, times f, which is 1 over x. To multiply two fractions, you multiply tops and bottoms. That'd be 2 over x times x plus 2. You could distribute the bottom if you'd like, but you don't have to. Your domain is going to be the same that it's been, and I haven't been putting it on all these, but x is not 0 and x is not -2. And that's going to be the same thing on these other ones that I didn't write. Now, D part, we're doing f divided by g. Again, f is 1 over x, divided by g is 2 over x plus 2. Now we know that, again, anything that makes the bottom equal to 0 is going to be also excluded in our final answer. So right now, x can't be 0 and x can't be -2. So to divide two fractions, we're going to flip the second one and we're going to multiply. On top, you have 1 times x plus 2, which is x plus 2. On bottom, you're going to have x times 2, which is 2x. The only thing that now in our final answer that would make this bottom equal to 0, 2 times 0 would be 0, so we're going to have to throw out 0, but we've already thrown it out. So our domain is x can't be 0 and x can't be -2, just as it was before. Okay, in example 5, let's look at our domain. For example 5, f of x, let's see, if I were to plug in -6, or you can do it like this. The stuff under the radical must always be greater than or equal to 0. You can't take the square root. This can't be negative, so it must be greater than or equal to 0. Move the 6 over, so that means x has to be greater than or equal to -6. So x can be any value from -6 to infinity. That's going to be your domain for the first one. And you can test that out. If you plug in -6, you get the square root of 0. Plug in -5, you get the square root of 1, and then it gets bigger and bigger from there. On the second one, the x minus 2, the stuff under a radical must be greater than or equal to 0. Move the 2 over, so that means that x has to be 2 or bigger. So there's your two domains. Anytime you're adding, subtracting, multiplying, or dividing, it must be the intersection, or both must be true. It must be satisfied. So my first one, -6 to infinity, would be all values from here over. 2 to infinity would be all values from here over. So which values are included in both? That would be the values from 2 to infinity. That's going to be your combined domain. So since it must be true for both, these values right here do not satisfy both. It only satisfies this one, so we've got to throw those out and only include the values in our domain that satisfies both. So now it's pretty easy. G plus f would be root x minus 2 plus root x plus 6. Nothing we can do to combine those, and they're not like terms. And our domain would again be 2 to infinity. F minus g, and yeah, I got those right. F would be root x plus 6. We got to subtract root x minus 2. Nothing we can do to combine them. And our domain is 2 to infinity as well. C part, we're multiplying g times f. Now we can multiply square roots. So the square root of x minus 2 times the square root of x plus 6 will equal the square root of x minus 2 times x plus 6. You can leave it like that, or you could actually multiply it out. The square root of, that'd be x squared plus 4x minus 12. So either one of those would be fine. Our domain, which, by the way, you cannot split the square root. A lot of people try to do that. You can only split square roots when it's being multiplied. So you could split this one, but anytime you have terms, you cannot just break that apart into the square root of x squared plus the square root of 4x. Don't try to do that. Your domain would again be 2 to infinity. And the last one, f divided by g, and our f was square root of x plus 6. And we've got to divide that by the square root of x minus 2. We're going to have to throw out anything in our domain. Before, again, our domain was 2 to infinity. We're throwing out anything that's going to make the bottom equal to 0. If you were to plug in 2, you get the square root of 0, which is 0. So the 2 is what's going to get thrown out. So now we're going to still be 2 to infinity. We're just not going to include the 2. Now, a lot of people will leave their answers like that. I am going to go through the process of what about if we wanted to rationalize? What if we want to get that radical off the bottom? So just for extra practice, let's multiply top and bottom by root x minus 2. The bottom becomes just plain old x minus 2. Any root times itself just gets rid of the root. And on top, we get the square root of, and this would be, we've already multiplied that. We multiplied that in the last problem. That'd be x squared plus 4x minus 12. And again, there's your domain. Okay, last example here. Now, these are going to be very important to you, and this is the reason I gave you that definition the way that I did. F plus g. I want to remind you that f plus g of x is equal to f of x plus g of x. Now, this one says find f plus g of 5. So let's first find out what is f plus g. That would be f plus g is equal to 4 minus x squared plus 2x plus 8. Combine your like terms. I'm going to put my x squared first plus 2x plus 12. Now, what does this mean? Find f plus g and then of 5. That means find f plus g and then plug in 5. So we can now take and plug in 5. That'd be negative 5 to the second plus 2 times 5 plus 12. That's going to be negative 25 plus 10 plus 12, which gives you a value of negative 3. Now, here's why I wanted to show you this. Instead of doing all that work, it is okay to actually find f of 5 plus g of 5. So instead of going through all that, you can work them individually. F of 5 is 4 minus 25, which is negative 21, plus g of 5 is 10 plus 8, which is 18. Negative 21 and 18 is actually negative 3. So it saved you a lot of the work that we did. So to find f times g of negative 2, again, you can do f of negative 2 times g of negative 2. You can do it either way. You can compose them, or excuse me, multiply them and then plug in negative 2, or you can plug in negative 2 and then multiply them. Either order works. F of negative 2 would be 4 minus negative 2 squared is 4. 4 minus 4 would be 0 times. It really doesn't matter now what g of negative 2 is, but we'll do it anyway. 2 times negative 2 is negative 4. Negative 4 plus 8 is 4. 0 times 4 is 0. So again, it is possible to do them together and then plug it, or plug it in and then multiply the two together. Either way would be fine.